In a previous lesson, we saw how to select elements or blocks from pandas data frames using the values in the index or the column names. NumPy arrays lack index labels or column names and so only support positional access. Selecting elements in NumPy arrays is like the selection of elements in a list with one important difference. Lists only support selecting using a single slice. NumPy arrays support simultaneous selection in each dimension of the array. Open the Lesson 11 notebook. I am using PyCharm for this demonstration. Start by importing NumPy and creating 3 arrays that we will use in this lesson. X is a 5x5 array containing the values 0 to 24. We create this array by first calling aRange25, which will produce a one-dimensional array with the required 25 elements. This array is then reshaped to be 5x5. Here, I chain the 2 calls together. Next, we can use aRange again to create a 5-element one-dimensional array. Finally, we can use the same aRange call and call reshape on its output to create a 5-element array with 2 dimensions, and so the argument for reshaping is the tuple containing 5, 1. NumPy arrays are like lists, and so use zero-based indexing. The first element corresponds to position 0, the second to 1, and so on. X has 2 dimensions, and so to select a scalar, we need to provide both. In a 2D array, the row is the first index position, and the column is the second, so here we can use x bracket 0, 2 bracket to select the element in row 0, column 2. This, of course, is the first row and the third element in this row, since both use zero-based indexing. Y is a one-dimensional array, and so only needs a single value. 2 selects the third element. Z is a 2-dimensional array, and so also needs 2 index values. First, we can look at what happens if I only provide 1, the row. Running the cell containing z bracket 2 produces an array containing 2. This is not a scalar. The element 2 is in the third row and only column, which is, of course, the first. We can select this element using the positions 2 and 0 for the column and the row. Scalar selection uses brackets in one or more integers. A key feature of scalar selection is that the dimension of the selected value is less than the dimension of the original array. For example, when selecting from a 2-dimensional array using a single scalar, the vector returned is one-dimensional. When selecting using 2 scalars, the value returned is a scalar and so not an array. However, this scalar can be interpreted as a 0-dimensional array, and so we've lost 2 dimensions by using 2 scalars. Wrapping a scalar in a list prevents dimension reduction when it is important to retain the same dimension after selection. The second row in X is selected by only providing the row position. Here we use x bracket 1 bracket to select the entire row. The second row in X can be selected by only providing the row position. Here we use x bracket 1 bracket to select the second row. If we check the shape, we see the output of this selection is a one-dimensional array with 5 elements. This occurs since when we perform scalar selection, we lose a dimension. Next, we can select the second element of z. This is also a one-dimensional array since z is 2-dimensional, and scalar selection removes a dimension. Slices can be used to select elements in NumPy arrays, much like they are used in lists. The key difference is that all dimensions can be simultaneously selected. For example, in a two-dimensional array, it is possible to slice only the first or to slice both the first and the second dimensions. Slice selection always preserves dimension. The trivial slice, a colon, is used to select all elements in a dimension. It is equivalent to a slice from 0 to the number of elements in the dimension. It is required when selecting all elements in a leading dimension, although it is optional in trailing dimensions. We can use the slice 1, 2 to select only the second row. This slice begins with 1 and ends with a number before 2, which is of course 1. Here we see the selected slice has two dimensions. Note the two sets of square brackets in the array printed. This shows that slice selection preserves dimensions. Explicitly checking the shape shows the selection produced an array with 1 row and 5 columns. Repeating on Y, we see the same slice returns a one-dimensional array containing 2. Finally, using the same slice on Z returns the second row of Z without reducing the dimension, and so the array returned is two-dimensional with 1 row and 1 column. The shape of this selection is 1, 1, which confirms that it is a two-dimensional array. List selection uses lists or arrays containing integers. List selection chooses the rows or columns in the position of the values in the list. In practice, it is only safe to use a single list, although a list can be safely paired with a scalar or a slice to select in multiple dimensions. When using multiple lists to select both rows and columns, it is necessary to use np.ix, which transforms lists of rows and columns into the appropriate shapes to select all elements in the product of the two sets of coordinates. Using a list, we can select the second row of x using bracket 1 bracket. The outer brackets are used to select elements from x. The inner brackets are the syntax for creating a list. Running this cell produces a two-dimensional array with 1 row and 5 columns. We can confirm this by explicitly checking the shape of the selection. Selection using a list on Y produces a one-dimensional array since lists do not reduce the dimension. Selection using a list on Z returns a two-dimensional array for the same reason. The next problem asks us to select a column using all three selection methods. First, we can select using an integer. We want all rows, and so we tell NumPy to include all rows using the trivial slice, a colon. This is followed by 1, which selects the second column. Running this cell, we see this selects a one-dimensional array. Checking the shape confirms that this is a one-dimensional array with 5 elements. Next, we can select the columns using the slice 1, 2, which will select a single column. Here the selection is two-dimensional since slices preserve dimension. Finally, we can select using a list with a single element 1. This also selects a two-dimensional array containing the second column. Next, we look at selecting multiple columns. Both methods can be used here. First, we select the second and third column using a slice 1, 3, which selects the items in position 1 and 2, but not 3. We can also use a list containing 1 and 2. Slices are flexible methods to select regular blocks. The full syntax matches that of range and takes 3 arguments: start, stop, and step. Using all 3 produces a sequence start, start plus step, start plus 2 step, until start plus m times step is greater than or equal to stop. In all cases, stop is never included. It is also possible to use negative slices to select the final n elements in an array. This is known as tail selection or tail slicing. This can be generalized to select elements starting from n elements to the end until element m from the end, where n is larger than m. Finally, a useful slice is : -1, which is used to reverse the elements in a list, a NumPy array, or a data frame. The next problem asks us to select blocks of rows from X. Selecting disjoint columns is a bit more difficult. Using the step argument in a slice, we can select rows using 1, 4, 2, which chooses 1, 1 plus 2, which is 3, but not 1 plus 2 times 2, which is larger than the stop value of 4. Using a list is simpler here, and a list containing 1 and 3 selects the 2 rows. We can select blocks using 2 slices, or a mix with 1 slice in another list. We will see that using 2 lists can produce unexpected results. First, let us use 2 slices to select the block. We want the second and fourth row, and the second and third columns. We can use the 3-argument form of a slice to select the rows, and the 2-argument form of a slice to select the columns. This chooses the correct block. Next, let's select using both a slice and a list. First, we use the slice 1, 4, 2 in the first position to select the second and fourth rows, and the list 1, 2 in the second to select the second and third columns. This produces the correct value. Then, we take rows 1 and 3 with the list, and the columns using the slice. Again, we have the correct block selected. Finally, if we try 2 lists, we only get 2 elements. This happens since when you use lists, NumPy treats these as positions. This combination has selected the element in the 1, 1 position and the element in the 3, 2 position, which is the diagonal of the block we want. The solution is to use the function np.ix when we want to select using lists. Using the ix command, we can select the block we want using 2 lists. ix reshapes the lists into arrays, one a column and the other a row array, which produces the correct selection. Calling ix without selection shows how the inputs are transformed. Running the cell, we see ix produces 2 arrays, one with 2 rows and 1 column, which contains the rows, and the second with 1 row and 2 columns, which selects columns. We can directly select the correct block of values using 2 lists of lists. These are like 2-dimensional arrays. NumPy treats the values in the lists of lists as the rows and columns to select from the array. The shape of the lists of lists is used to determine the output shape. This produces the correct block, but is tedious to use. Converting a NumPy array to a data frame requires calling pd.dataframe on the array. Converting the other way is simpler and can be done using dataframe to NumPy. This is the safest method to convert to an array. The alternative is use a NumPy function, asArray, which will convert, if necessary, anything that is like an array to a NumPy array. Finally, we see how to convert a pandas data frame to a NumPy array. This first block wraps X in a data frame with columns and index labels. We can use the method toNumPy to extract a NumPy array from a data frame. The values in this array can then be accessed directly using the numeric indexing demonstrated in this lesson. Alternatively, we can use the NumPy function asArray to convert the data frame to an array. This command can be used to turn any array-like object into a NumPy array. While you could have called array on the data frame, asArray is a better choice since it can be more efficient than array in some cases. We have seen there are three methods that can be used to select from an array: scalar integers, slices, or lists of integers. These can be freely mixed to select in more than one dimension, except when using multiple lists, in which case IX is required.